right, so we'll go ahead and get started. According to the phone, it says 10:45. Let me just first update you on the updates I've done. You may have seen the announcement, but we'll go over here to Canvas. Let me go to student view just to make sure everything that I want you to see is viewable. So we've actually finished up chapter 13, all the content in there. So if you click on that one, you'll see we've got the 13.1, got lectures and some problem solving from the Zoom class. We've got the lecture followed up by some other questions being solved for 13.2, 13.3. We've got a lecture and again some problems. I worked two of the four problems types, so we went through some of those. And then what I've got posted from yesterday is the indefinite integral 13.4. This morning, I posted, we're starting into chapter 14 on integration techniques. Let's get you admitted. And so you'll see this, I've got, I didn't actually even use the PowerPoint. The PowerPoint, I thought it got too much into explaining why instead of how. So I focused on the how. I worked through every type of problem that you will be facing in the homework. So that's there. If you click on this, you'll actually even get the solution. So if you kind of do better by just following work on a page, it's all in here recorded. I've also got this in there as a blank sheet so that, you know, maybe you could go back through and practice, and the video works through these so you can see the order that things came in. But they're all solved here. So we've got the solutions, how it worked. And again, we each have our different ways of doing things. So try to give you multiple resources, and then we'll be working out the next 4.2 on Friday. And then next week we'll get 14.3, 14.4, and 14.5. And then we'll have a week where we have no new content and we can review. And then we've got finals week, which we don't have any scheduled meetings, but I'd be happy to do a review session. We'll talk about that after we get through next week. But we still have our final exam scheduled for Thursday, but that's May 7th in the evening. We're going to use that same time. And as we get a little closer, if you have conflicts, let me know. But otherwise, that's the best time it's been scheduled from the beginning. So let's see how we do. So with that being said, any questions? Come back here, make sure. So my volume's up. No question.
So we're not going to go over 14.1 today at all?
It is, the video for 14.1 is there.
Then I have a question for the last chapter.
Okay, sure.
Let me just pull it up real quick. Sorry.
No worries.
Can we go over number 8 from 13.4?
Sure.
Using the numbers from like mine? Because I tried it a few different times. And I got half the answer right, I think.
Okay.
When I do like the practice one, like I got half of it right, but I can't get the other half right. So do you see like number 8 and 13.4?
Number 8?
Yeah. So it's like it's 7x. I don't know what you have, but mine's 7x over x squared plus 2, and then the squiggly line with 1 and a 0.
Okay, let me, got a few more people added in. Let me get my Let me share my screen first, and then I'll get a Word document up there. That. So yeah, we can work on any of the questions you might have. So you had the integral of 7x.
7x over x squared plus 2. And then it was a 1 and a 0.
A 0 and a 1, 0 at the bottom and a 1 at the top.
Yeah.
Okay, got it. Okay, so this, let's see, this is indefinite integrals. Notice these are both x's. So one way we should be able to do this one is
this is 13.4.
This is 13.4, yes.
All right, cool.
So when we have a definite integral, what we need to do is this is going to be a numerical answer. And let's see, use the shortcut. Let's see if we can, so we should be able to just graph this. And when we have a fraction, one easy way to do this is if you do alpha f1, which is y equals, it gives you a fraction. So we go 7x. And you'll see actually in today's lecture, there's one problem that they give you. And instead of doing integration by parts, you can also do it with the calculator. Okay, so we put in 7x over x squared plus 2. We go second. No, not second. We just go to graph. Just graph it. Of course, we can't see anything. Let me do a zoom standard and see if we, okay, so there's our graph. We're going to be graphing between 0 and 1. So what we do is second calc. We do 7, which is integrate. The lower limit is 0. Enter. The upper limit is 1. Enter. Notice it fills in there, and we've got 1.419. Which they're probably not. Have you tried that, Jacob?
I have not. I did it a different way. I did not know we could do it with our calculator. So this is actually super helpful. Let me try putting in 1.419.
Okay. Yeah, let's see if it works. It may not take it, and then that means we'll have to do it by hand. But because there was some earlier that I was doing, and when you do it with a calculator, that's great, but they don't take, they want an exact answer.
Yeah, this one is not taking it. Should I try it as a fraction instead?
Well, if you can make it into a fraction, it might not, but yeah, that would be the case. Let's see.
It'd be 1.419 over 1,000.
Yeah, but even that is because it's got the decimal goes on is some kind of rounding. So let's see what. Let me remember what this section was about. This was the definite integral. Okay, so what we're doing is we need to. We can do this with u substitution. And we let u be equal to the part in the denominator.
I actually did it a different way. Maybe that's why I did it wrong. Maybe I rewrote the equation as 7x times x squared plus 2 power -1.
Okay.
Is that wrong, or is that
No, that's the other way yeah, you could do that either way. We
that
could
one
do
was
that.
this way is easier for me to understand, and that's the
Okay.
way I did it.
So we would still let the substitution will be this part, right? So then du is going to be 2x dx. Divide both sides by 2x so that dx, yeah, is equal to 1 over 2x du.
I actually did mine completely differently without substitution.
Okay.
I took the derivative of I did 7x times x squared plus 2 power -1, and then I took the derivative of it, so I changed it to 7x squared times x squared plus 2, just zero now, just regular 0. And then I plugged in the values like that, and then subtracted, and then yeah.
Okay.
So like 1 times 7 is, you see where I'm going with that?
Yeah, but you can't distribute the 7x into this because it's a -1. Had this been to the 1 power, the positive 1 power, we could do that.
Oh, but because it would not work if the exponent was 0. That's where I'm wrong.
Well, right. Yeah, with
So
this one
that method never works if the exponent is 0.
would well,
The antiderivative of the exponent was 0.
we can. I mean, you could think of 2x to the 0, but the problem is we've got we've got a multiplication here, so that would be like a product rule, and it's not and there's no way to get this to be a polynomial with multiple parts. Okay, so what I hear you saying is you took the 7x and multiplied it in here, and we can't do that because this is to the
No,
negative.
that's not what I did. I took
Okay.
the 1 value and plugged that in for x, and then I subtracted the same equation, but instead of the 1 for the x, it was 0 for the x.
Well, right, but what I'm saying is to get the function that you need, really the only way to proceed with this is with u substitution.
I see.
Yeah, because otherwise, I mean, you could probably do a guess and check, but if it worked, you'll end up the same place that we would end up here. But so let me continue on here with u substitution. We put u here to the -1. Let's see, we've got our dx. Our dx becomes 1 over 2x du. So I'm going to put the du here and the 1 over 2x up here. So then we get 7x over 2x. And notice the x's cancel. So our integral becomes 7/2, the integral of 0 to 1, u to the -1 du. And what does that integrate to? Anyone? This one is one we need to remember.
Would you be, I don't know.
Right? Natural log of u. U to the -1. That's why I was, what I would have had is 1 over u du. I would have got, so the other way is to work it this way. I recognize this as when it integrates, it's going to be natural log of u. This is the same thing, natural log of u, again, 7/2. And this is why they're looking for an exact value. So what your answer needs to be is, again, yeah, you plug in 1 for, well, actually, we're not done yet. That's not what goes in here. Our answer is 7/2. We have to put what u actually is, which is x squared minus 2, or x squared plus 2. And then we put in our numbers. see. So your final answer, what it's going to look for is 7/2. We plug in the 1. 1 squared is 1. 1 plus 2 is 3. Minus, right? We minus the second one. We put in 0. 0 squared is 0 plus 2 is 2. So then we get 7/2 natural log of 2. And that's the exact answer they're looking for. I think if you plug that in, you'll have a correct answer. But that's really the only method we have for integrating something like 7x, x squared. And the way you have to notice it is using the chain rule. The inside, the derivative of the inside is 2x, and that's where that x is.
So that's the answer in the square?
Yeah, that's the answer that needs to be in the square.
Hey, Little Crow.
Yeah.
On the right-hand side, you set the, what do you call that little squiggly?
The integral sign.
Integral sign, okay.
Yeah.
Did you set both those to 0?
Oh, thank you. Yeah, I was getting sloppy. It should be 0 to 1.
Okay, cool.
Yeah.
Okay.
So I was just showing that these are equivalent. 1 over u is the same thing as u to the minus 1.
Oh, okay.
And either way is going to be it. What you have to recognize is when we integrate either one of these, what we get is natural log of u.
Gotcha.
All and right. Whenever our answer is natural log, even though we've got these numbers we can put in, this calculator method's not going to work because they want an exact answer, not an approximate.
Gotcha. Yeah. So when I tried to graph that equation that you put in,
yes.
I had two lines. One was on the left side of the graph. One was on the right side of the graph. Do you know why that is? Is that like a setting in my calculator I need to fix, or?
It could you put the exact same thing in?
Yeah, 7x over x squared plus 2.
One thing that might have happened is depending upon what version, what calculator do you have?
I got the TI 84 plus.
Okay.
I got the bulkier one though, not the one you got.
What you may have done is if you did it this way.
Yeah, look like that.
You need to have parentheses here because what it's doing is it's actually putting this out, and what you're getting an asymptote at 0.
Gotcha.
And something weird's happening. And then actually, you might even need to put a parentheses here.
Okay.
That groups the top and the bottom, and then you should get exactly what I got, and then be able to integrate and it'll be okay.
But that won't matter since it wants that kind of answer algebraically.
Exactly. It still wouldn't accept it. So you would have got what I got, and the system wouldn't have accepted it because it's wanting, it wants an exact answer. It doesn't necessarily say that, but let's see, we come back here. When it doesn't say, so what you can tell is that these ones down lower, calculate the region. There's some down here. Let's see this one, not that one, this one, number 13. Where does it say? Use the use definite integral to estimate the nearest million. So when we're estimating, we can use the graphing calculator for those. We can also use it when we have a polynomial because those will be a nice integer value without a repeating decimal. Of course, that could also get thrown off if there's a 1/3 or something. But these other ones where they don't say estimate or approximate, we need to provide an exact answer. And if your answer involves either a natural log or an exponential e to the x sort of thing, you actually need to enter those exactly as they are. So that's how the system kind of gets through and make sure you know how to actually take the integrals. I like the technical side. Okay, did that work for you, Jacob?
Yes, thank you. I have another question.
Okay.
Why is my camera showing? I just had a question with well, I got the problem. like number 13, 14, 15, like I get the problem, but the parameters are not very clear. For example, like we'll use like 13, for example.
Okay.
When we look at it, I'm sure your equation is different, but it says since YouTube, what does yours say? I can't see it. Hold on. Oh, I see it now.
Yeah,
I
yeah.
see. So like when it says that,
Mm-hmm.
0 to 9, those are the squiggly line parameters, but we're actually looking for like the parameters of like, so like 1 and 4 in between those years.
Right, because actually 0 to 9 is not the squiggly line. It's the 0 to 9 is just saying those are the years this equation works for. So they've been sort of tested. So that would be from 2005 to 9 years down the road.
So the parameters should be 1 and like 4 or 1 and
Right, because we're going from 2006 to 2010. And since 2005 is year 0, 2006 is year 1, 2010 would be year
5.
So yeah, so this, the one that's showing right now would be from 1 to 5.
Okay, so that's the, so okay, gotcha.
Yeah, and then this one's one we just graph it like we did over here, and then do from 1 to 5, and that'll get you your answer. But yeah,
Okay.
that's and like 14, same thing. They give you these parameters that t is the domain of t is from 20 to 50, but that's only relating. That's the whole domain. So then they actually help us, I guess, saying that t goes from 26 to 28. So. But this is our squiggly line, the integration, what they call those, the limits of integration. So this one, it would be going from 26 to 28. So they help you out a bit there. And same thing down here. The inequality they give you is simply the domain of this function, but the limits of integration they give you down into the question down here. So like number 15 would be, since for year 0 is 2004, this would be 2006 would be year 2 until year 6, which is 2010, 2 to 6. And that's within the domain. So it makes everything valid. Good. What else? Anything else interesting or question? Yes.
Professor Crow,
Yes.
for number 1, so I did a calculator part, but then when I put the answer from decimal into fraction, it still gave me the decimal, but then I had to like go and make into a fraction, which I got 28/3, but I'm not sure how you do it by hand exactly.
Okay. So like this one here, number 1, that's integral of x squared plus 1.
Yeah.
Okay. So is that what you have, or because your 1 might be different, or do you have
I got the same one.
Oh, it's the exact same one. Good, good. It's not too much. So let's just take a look at how we would, let me get this out of the way. Come on. So let's see, we're mostly, come on, move. There we go. Okay. And your limits of integration aren't the same?
It's the same.
Okay, exactly the same. Cool. -2 to 2 dx. So notice this is a polynomial, so we can integrate each piece. So this one will actually be easier to just kind of, probably easier just to do it this way. So we're going to add 1 to the exponent. So x squared integrates as x to the 3rd divided by 3, because that's the new exponent. Think of this 1 as 1 times x to the 0. So it integrates, you add 1, it's going to be x to the 1. So that's plus x to the 1 over 1, which is just just x, okay? And then we've got our limits here. We got -2 to 2. So we plug in the top limit first. So this is going to be 2 to the 3rd over 3 plus 2 minus, and then I like to put a parentheses because that minus is going to distribute, -2 to the 3. Maybe I should do it this way just to make sure we get the right value, over 3 plus -2. Again, this negative is going to distribute through. So let's see, 2 to the 3rd is 8. So we get 8/3 plus 2. This is going to be -2 to the 3rd. So that's actually -8 over 3. But the negative and negative makes this a positive 8 over 3. And this negative makes this a plus 2. Okay, and so 8/3 plus 8/3, that's okay. That's 16/3. 2 plus 2 is 4. And then we need to get a common denominator, which is going to be 3. So we multiply 4 over 1 times 3 over 3, which gives us 16/3. 4 times 3 is 12/3. 28/3, right? That's what you got, I think. Which kind of gets us dealing with, although you maybe could do it at this time and then use the function to turn a decimal back into a decimal into a, yeah. This would have given us probably somewhat either 0.333 or 0.666. I think should have been 0.333.
9.33 something.
Okay. So then, let's see, what else? So 9.3, I was, okay, that's going to be thirds. So 9, take 9 times 3, which is 27. So think of this as 9 1/3. And then 3 times 9 is 27. So you multiply and then add. You could do it this way, 28/3. But it's just recognizing the repeating decimal part. But yeah, it's a little bit, I think that what they're trying to do is find problems where they force you to really have to do it by hand. But there's a few in here where you can get by with the technology, with just using the calculator.
But okay, is this essentially just doing what we've been doing, but plugging in numbers once we found our final answer?
Exactly, you got it. That's really all that one was. Yeah, doing what we've been doing, but making it a definite integral. And so actually, we spent 2 lessons just to be able to do that. The one before this with the Riemann sums was just to convince us that when we were getting the integral, what we get is we get the area under the curve. That's really, and we had 4 problems. 4 is showing, okay, let's just get the area under the curve. So just integrate and then use the limits. And we got the area from that part of the curve. You're okay. Exactly.
And so will we be building off of this in 14.1, 14.2?
Yeah, we'll use it in some of the applications.
Okay.
And we'll see like 14, and so really there's no more new techniques for integration except combinations of these. So like today's lesson 14.1 is integration by parts, and so it's kind of like the product rule, sort of what we learned before, but it just breaks things in parts. We're really not doing anything new. It's just how we assemble it, and that's why you'll see I've got a matrix that helps you figure out how to do the assembly of the parts. And I think after you work through, at least watch them, work through a few with that, it'll become pretty clear. But it's yeah, in a sense, nothing really new, just the way things get assembled. And 14 primarily it'll all be applications. So we'll use some of these definite integrals to solve some things. I took a quick look at the last one. Yeah, I think that's primarily what we're doing now is just applying these to problems. So we get this opportunity to kind of come back and review and see, and we're going to see the same things over and over, and that's when things should start making connections. Then we have we have next week to kind of do that too, and then we've got a whole week where we don't have to, no new material. We'll just go back and review, and hopefully, what I'm hoping is that this part, typically in my experience, is much more understandable than stuff we've done before. And we really do have this benefit of not having to do a comprehensive final, but just have the final be basically test 3, where you could really focus on it and do real well. That's what I'm hoping, is that we can take this time and do really well on test 3, because I got a way where I can weight that much heavier. And again, for those of you who've already done well on the early tests, you won't be penalized if you don't do well, but it allows people to pull up grades that might not have been able to be passing grades before, but because of because of what's happened, I think it'll allow more students to pass the class and maybe get Bs and maybe get about a grade higher than would have been possible with the other grading system.
So with this final coming up, how much is going to be like figuring out on a calculator, if not, or is there going to be?
There should be some. They're still working on coming up with what the final exam will be. I did, thanks for reminding me. I did post, let me go back to my screen share. I don't think I mentioned it, but I did in the announcement, but let's come back here. I did put in the review, so they do have the review, but all the review is they took the last 2 sections from the final, put it on the review for 3. So this is here, and it gives some kind of an indication because they try to build a final based off of these. So here's 13.1 with the answers. Let's see, 13.3 with the Riemann sums.
And when is our final again?
It is Thursday, May 7th at 7 o'clock or 7:15. I'll have to, I think it's either 7 o'clock or 7:30 because it's based on a common final time. So it has nothing to do with when class meets. It's just all the 210s are supposed to be having their tests at that time. Now, some professors have like 2 or 3 sections, or some, I think there's a few that have 4 sections. And so instead of having them proctor all of those at the same time, which would mean over 400 students, they are allowing them to have the test during the standard time, which means earlier in the week. But I just said, let's give everybody the maximum amount of time to study. But I do put that caveat, if you do have a conflict with that final exam time, let me know and we can see. We have one other time, but it was, I think our scheduled time would have been like taking it on Monday, which cuts off several days of studying. So I thought it'd be to everyone's advantage to have the extra time for study. But I'm looking through here. Yeah, there's some, whenever it's going to have natural log of x, you're not really going to be able to just use the calculator. Yeah, we're going to look at area between 2 curves, so that will take off of what we've done. And the way you get area between 2 curves, you basically subtract, and so it's really the same thing we were doing, but with a little twist that we integrate 2 things to get there. let's see. Then we get to average value. Again, you'll see it's a definite integral, but we have a little formula because we're going to take the average of it. So instead of just getting the whole average, we get an average. So it's a lot of what, 13.4, but with we multiply by 1 over that, so we get an average instead. And we'll deal with surplus, and then we'll take a look at integrals going to infinity, which are called improper integrands. And for those ones, the calculator won't work because it won't find the integral. But again, I wouldn't expect maybe more than one out of each of these. And I should have the final exam, because he has to create a new one, and so I should have that sometime next week, and I'll take a look. So I would know how to use the graphing calculator, but also realize a lot of these methods need to be done by hand. So be comfortable with both ways of doing things.
Okay.
But the telltale word is if you find in a question where it says make an estimate or approximate, that's when we can definitely use the calculator. And now I'll go through and I'll count and I'll say, we got 13 problems. Out of the 13 problems, 3 of them you can use by calculator, whatever it is. I'll go through those and I'll give you that count on that.
Okay.
All right.
Is that it? Are we done here?
Well, I have nothing.
Okay, thank you, Professor. Have a good day.
You too. Anyone else? Any questions?
I have one simple question real quick.
Good. I like simple questions.
Where was it? I was just looking at it. Okay, number 4 and 13.4.
Yes.
So it's x plus 7 over x, so it'd just be ln of x plus x, or 1/2 x squared, right? And then you just do the...
Let me
Oh, wait, see, get to it.
let's see. Oh, okay. We're done. So say that again.
It's just x plus 7 over x.
Oh, wait. X plus 7 over x.
And then the bounds are 9 to 4. I can do the bounds. I just wanted to make sure that it's just ln of x plus 1/2 x squared, right?
You're right. Yeah, because this part would give you the x squared over 2. This would give you the 7 ln of x. And we're adding them. So yeah, you could do those in either order.
And since it's an ln of x, do you have to give it the exact, do you think, or can you just...
Yeah, and they got limits on here? Or they've got...
it's 9 to 4. It's 9 to 4, yeah, so they do have them.
9 to 4. So yes, and then you're going to plug those in, and since it's the ln of 4 and ln of 9 are going to be repeating decimals, so they're going to want those actually put in.
Okay,
So yeah.
Instead of putting in like a number, just put in the whole equation. And then
Yeah.
minus. Okay, gotcha.
Exactly. They want exact numbers.
Okay, thank you.
Yeah, I did that first. I said, oh, this is going to be so easy to teach. Just all get out your calculators, do them all, and then I put them in. I go, what? It doesn't accept it. Okay. And it took me 3 tries, and then finally said, I bet you they want the exact answers, and they do. And so anyway, we did it.
Okay, thank you.
Very
Have a
good.
one.
All right. So if there are no more questions, going once, going twice.
Little Crow, have you seen Star Wars?
Which one? The latest?
The third one.
Probably. It's been a few years though.
I was watching it last night, and
Yeah.
I gotta say, you look exactly like Count Dooku. That's a good thing.
Thank you. He's pretty handsome. Yeah.
I was looking at him. I was like, dude, that's Little Crow.
Dude, holy shit, that's so accurate.
Yeah, I know, right?
Well,
I thought that
cool.
was cool. I just wanted to share.
Thank you. Thank you. Actually,
Yeah.
just a little since we're here, I did see the original Star Wars when it came out. My dad built a little. They were back before satellite television. They had these systems that set up. My dad built a system to pirate it. So it was real fuzzy, but we pirated the original Star Wars back in the day.
That's awesome.
Yeah. So
That's
anyway.
cool.
Cool.
Well, have a good one, Little Crow.
All right, you too. Everyone
Have
stay
a
safe.
good one. Thank you.
Have a good one. We'll be in touch. All right.